Okay, so carbon and hydrogen, is that a polar or non-polar bond? Polar. Which end's positive? Hydrogen end is positive, so that'll be a partial positive, partial positive, partial positive, partial positive, partial positive, partial positive. Are they evenly symmetrically distributed around the molecule? So which way? We go from positive to negative, don't we? Negative to positive. So that's the direction of all of our dipoles. So overall, they'll all cancel each other out. So we have a non-polar molecule. What about bromomethane or bromoethane? So we know that these guys are all positive. What about this one? Is that going to be polar? Which end is going to be the negative? Which end is going to be the positive? Emmy, which one's going to be the negative? The bromine end will be negative. So, do we have symmetrical distribution of charge? No. So what's that going to be? Polar or non-polar? It'll be polar. So we will have a net charge in that direction, won't we? Thanks. This one here. So overall, polar or non-polar? Polar, which will have an overall dipole in that direction because these two are the negative ends and that's the positive side. So we've got hydrazine. So here we have a couple of electrons and then we have positive, 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 positive. So is that polar or non-polar? So we have positives around there with the negatives around here because this is negative, this is negative. So this geometry over here is the same as this kind of geometry here. So we have negative charge. I'll get rid of those electrons. We've got partial negative on this side, partial positive on that side. So that's a polar molecule. It's got a negative end and a positive end. So that one's the only one that's non-polar because it's symmetrical. The charge is symmetrical. These ones are not symmetrical, so they're all polar. Yep.
Like when you say symmetrical, the third one, you cut it like on the y-axis, then it becomes symmetrical.
Yeah, but it's not symmetrical that way.
So which axis do you choose?
Yeah, it's not a great term. You need to think of it in terms of, is there a side of the molecule that's got a different charge to another side of the molecule? Is there an uneven distribution around the outside of charge? It's probably a better way to think of it than using the term symmetrical and asymmetrical. Yep. So they go from positive. Sorry. Yep. So they go from positive to negative. Yep. Okay, so what about those ones? So this one here, we can see that we've got positive charge around the outside. So that one's going to be non-polar, isn't it? What about this one here? What shape molecule is that? Linear. Does it have a positive charge at one end and a negative charge at the other end? So what's it going to be? Non-polar. This one here, what shape molecule is that? Trigonal planar. Yep, carbon's got all of it, so that doesn't have another set of electrons out here, so it's trigonal planar. What charge do we have at this end? What charge do we have at this end? So it's polar. This one here, what shape is that? It's bent. Is there an uneven distribution of charge across these? Which one's going to be the positive end? Which one's going to be the negative end? Well, sulfur, oxygen, which one's more electronegative? Oxygen's in period 2, sulfur's in period 3. They're in the same group. So which one's has got a higher electronegativity? Oxygen, because it's got a smaller atomic radius. So this is going to be the partial negative end, this is going to be the partial positive end. So that's going to be a polar molecule. Okay, so these are the types of questions that we will ask when we're dealing with polar and non-polar. It's more of an application of it. So beryllium BH2 is not polar, but H2O is polar. Why? And then SO3 and NH3, they appear to be the same. Why is one not polar and the other one is polar? Okay, so remember, go through those steps that we went through. First of all, identify the molecule shape. Secondly, identify the polarity of the bonds. Thirdly, look at the distribution of charge around the molecule to work out whether it's polar or non-polar.